Okay, good morning. Welcome back. Happy Wednesday. Today we are covering something called in-context linear problems. I will point out a couple of things coming up. First of all, tonight's homework is a supplement. It is not at all in the textbook. It is entirely in the homework packet. So if you look at the homework assignment, it'll say, see problems a few pages later, and you just flip through and you'll find the ones that say class number 9, which is what we're doing today. Also coming up on, let's see, Friday there, Monday is quest number 2. That quest covers the material from lessons 6 through 9, so 6, 7, 8, and then what we do today. So once we finish the material for today, we're done with the material for the quest. So according to the calendar, on Friday it says catch-up day, and so that was a day that I had planned for us to not do anything new, and I would just walk around and you would study for the quest and kind of catch your breath a little bit. I'm almost tempted to change the catch-up day to a later date during the semester. The material typically tends to get really hard for students down here when we talk about radicals and exponents, and I'm wondering if it might make more sense to take that catch-up day out of here and just insert it someplace down the road when it feels like we're really needing a moment to stop and catch our breaths. I haven't decided about that. It's not anything you need to worry about, but I'm just giving you a heads up that on the coming Friday, we might actually jump ahead and just start some more new stuff. It won't impact the quest. It won't impact homework due dates, but I'm thinking about changing things around just a little bit. So I will let you know. Okay, any questions on the calendar? All right, so let's go ahead and jump in here on page 68. In this lesson, we use real-world data to find equations of lines. We then use our equations to solve problems. I'm hoping this is starting to sound familiar. We have been doing this for a few weeks now. Figure out 2 points that are on a line, find the equation of the line, use the equation of the line. I want us to be really good at that process. Okay, this is a calculator active problem. Sales for personal breathalyzers have spiked in recent years. In 2009, the personal breathalyzer market was valued at $215 million, up from $28 million in 2005. So we are going to assume that sales are growing at a constant rate. So going from 2005 to 2009, let's assume it's a straight line that will connect us from 28 million up to 215 million. Ultimately, we're going to find the equation of that line and use it to make some prediction. But first, we need to define a couple of variables. So let's highlight up here. I've got 2009 and I've got 2005. And then I've got 215 million and 28 million. So the 2 yellow things and the 2 green things. Those are our 2 variables. One of them is measuring the value of the breathalyzer market, and the other one is measuring time. Which one is our independent variable? Which one is independent? The value of the market or time? 1 vote for value of the market. Say it again, nice and loud. Say it loud. What depends on the time? That's right. The value of the market is the dependent variable because the value depends on the time, right? Time is independent. Time marches along independent of anything else, and then other stuff changes as a result. In this case, it's the value of the market that's changing. So let's fill that in. So we will let x equal time. But you can't just say time. You have to tell me what unit you are looking for. So what unit are we measuring time in? Years. And so when I grade your next quest, and when I grade your first test, and when I grade everything that you have to define variables on, I'm going to be looking for 2 things, a quantity word and a unit word. We've got them both. Time is the quantity. It is measured in the unit years. At bare minimum, your definitions have to have 2 words, quantity word, unit word. Now, it's totally fine for us to stop right here. Time in years is cool. But if we do that, that means that we are going to use the number 2009, literally the number 2009, which is a fairly large number in some contexts. And I want to make that number friendlier for us. So how about we decide we're going to start the clock in the year 2000. Which means that 2009 changes to what number for us? 9, which is a whole lot friendlier. Everybody see what we did there? You don't have to do that. You can just leave it time in years, but that means you are using the number x equals 2009. I'd rather use 9. Okay, dependent variable looks like it's the value of the market. Let's go ahead and fill that in. Y equals value of market. Remember I said I'm looking for 2 words, quantity word and unit word. Value is a quantity word, but we don't have the unit yet. What is a unit? Millions of what? Dollars. That's what we want to do. I'm going to put dollars here for just a second in dollars, and I'm going to leave a space there, which we're going to fill in momentarily. This is a totally fine definition. Y is equal to the market value in dollars. That's fine. But if we stop right there, then when we are writing an ordered pair, and I see that 215 million, what do I have to put here? 215, and then what? 1, 2, 3, 4, 5, 6. If you choose to let Y be in dollars, it's fine. But that means you are literally writing the number 215 million and doing the calculations that we're going to do with 215 million. Again, we want to make a friendlier choice. Millions of dollars, which means I get to just write the number 215. Everybody see it? So we're making 2 choices to make things easier for us. Okay, so we've got our variables clearly defined. We've got stuff highlighted in green and yellow. We just have to translate those things into ordered pairs. First one is 2009 and 215 million. What am I putting here? 9, comma, 215. Both friendly numbers. Take a moment, write down the other ordered pair. Okay, who's got it? 15? 5. Oh, yeah, 5, comma, 28. I've seen some folks get confused about this up from 28 million. Some people start like adding the 28 million to the 215 or subtracting the 28 million from the 215. It's neither of those. Up from 28 just means it was 28 and then it went up to 215. Okay, so it's just 28 there. All right, and now we've got 2 points, 2 ordered pairs. And so now we can find the equation of the line, and we can ignore all of this context about the breathalyzer market, right? It's just the same process we've been doing for a few weeks now. So let's do it. Start with the slope. Upstairs, 215 minus 28. Downstairs, 9 minus 5. I think that's a 187 on top, 4 on the bottom. So this is a calculator active problem, so if anybody happens to feel like helping us out here, just shout out the number, otherwise you're going to see me stumble and fumble with long division. 4, 6, is that right? 46.75. Okay, and now we've got the slope. So the next thing we're going to do is find the y-intercept. So we'll write our standard y equals mx plus b. We'll change the m to the new number we just found. And just putting that plus b there, that's a powerful moment. That's our way of saying, I don't know what the b is yet. I'm not supposed to be able to just look at all these numbers and figure out what the b is. We got to do some calculating. So we're going to plug in an x and a y. You can use either orange point. For me, it's a clear decision. If I've got smaller numbers in one, I pick that one. But you can use either one. I'm picking 528. Make sure you put them in the right spots. 28 equals 46.75 times 5 plus the b, which is about to be determined. And again, somebody with a calculator. 230. Is that 233? All right on that one. And then we'll subtract the 233 from both sides. Thank you. So that's our B, negative 205.75. And so then we get to write our final equation of the line. It starts here. Y equals 46.75x. But then instead of plus B, I'll just put minus 205.75. And like I said, we've been doing this process for a few weeks now with the mx plus b. You find your slope, you find your y-intercept by plugging a point in, and then you just recopied the equation. Any questions on that equation? Okay, next part here says interpret the meaning of the slope. In this context, write a sentence in plain English. So first of all, we need to make sure the number, the slope number is in the sentence. What is the slope? 46.75. So that's going to be in our sentence, but we got to figure out what that 46.75 represents. I know that every slope represents some kind of rate of change. I need to figure out what's changing. And the way that I always do slope interpretations is to start with the units. So let's come back up here to our purple calculation. 215 and 28. What were the units of those two numbers? Millions of dollars. Millions of dollars, right? That's on top. Downstairs, I had a 9 and a 5. What were they measured in? That was years, right? 2009, 2005. So that means that my slope, the final number 4675, the units are millions of dollars per year. $46.75 million per year. Something was changing at $46.75 million per year. What was changing? Breathalyzer market value, right? That's what was changing. Was it increasing or decreasing? Increasing, because 46.75 is what kind of a number? Positive, right? If it had been a negative, we would have had a decreasing value. So then we just have to add a couple of words and we've got our sentence. The market value was increasing at $46.75 million per year. That's what we're looking for the interpretation. I've seen some students go a little bit wacky on the slope interpretation sentence. Like they start writing stuff about, you know, the negative 205.75, the y-intercept. And like, you know, you can write true things about what that negative 205 means, but you don't need it. I'm just looking for an interpretation of the slope. Some people will describe to me how they calculated the 46.75. They'll say, oh, I subtracted, you know, 215 minus 28 in the numerator and 9 minus 5 in the denominator, and I divided. Yeah, okay, that's fine. That's how you calculate. I see how you calculated the slope already. I want to know what the slope means, okay? So it's just got that one number in it, just the slope number. Tell me that you understand what rate of change it represents. Okay, and then finally, E, predict the value of personal breathalyzers that will be sold in 2015 and interpret your solution by writing a complete sentence. Okay, so let's do that. 2015, we just got to translate. So first of all, is that an X or a Y? 2015 is an X, that's a time, right? What's the value of X that corresponds to 2015? It's just 15, right? We're not using 2015, we're using 15 because we started the clock in the year 2000. So that means all we do is take our equation right here and just plug in X equals 15. So Y equals 46.75 times 15 minus the 205.75. So with a problem like this, the most common way to get it wrong is to not realize whether you're replacing X or Y. Right? One of them is becoming a 15 or a 2015. So just pause, don't guess. Take your time, make sure you understand what does X represent, what does Y represent. Hopefully you've written clear definitions like we did at the top here, and then it's just a matter of substituting. Okay, somebody got a number for me? Thank you. 495.5, and then we'll just write our little sentence. Sentence just needs to contain the two numbers, 2015 and 495.5. So here we go, something like in 2015, market value is 495.5. Yeah, so if I write that sentence, I'm losing a point. Or more specifically, if you write that sentence, you're losing a point. What did we omit in that sentence? Million. It's millions, right? It's not $495, but that's what it says. It says $495 currently. That's not right. 495.5 is a fine answer for this plugging into the equation. That's the right answer for plugging into the equation, but our interpretation has to include the millions. That's a full credit sentence. In 2015, market value is 495.5 million. Truth be told, that's just an estimate. I don't know what the market value was in 2015. According to our line, it was going to be 495.5. I don't need you to say that, but I'm just sort of putting it out there. The sentence looks like we have more certainty than we actually do. Yeah, I think that's good. Any questions on that? Okay, so the activities start on the next page. No, they don't. Activities start 2 pages down the road. I will point out all these problems are calculator active. So I'll go ahead and grab some calculators. You can borrow one if you don't have one. Feel free to use your phone if you'd like. And raise the flag if I can help.